Subtracting integers with counters and zero pairs. All right, here we go. We've got our supplies. The first thing we're going to do is jot down some information about our key vocabulary word. You might remember this from when we did adding integers with counters and zero pairs. We're just going to jot down what in the world is a zero pair in case you have forgotten. Our definition is a positive and negative that cancel out. I have $1, I spend $1. I owe $1, I pay it back. Either way, I'm left with 0. So an illustration would be a positive and a negative that cancel out. Some examples would be like, I owe my friend $5 and now I pay them back $5. A non-example would be, I owe my friend $5 and I pay them back $3. I haven't zeroed out my balance with them because I haven't paid everything back just yet. All right, so we know what a zero pair is. Now we need our basic rules that we're going to be applying when subtracting integers, because there are a little something else to consider when we're working with subtracting integers. The first rule is 2 negatives make a positive. All right, we've heard 2 wrongs don't make a right, but in math, when we're working with negatives, 2 negatives do make a positive. And then the other big thing we're gonna see is that the subtraction sign and the negative sign are the same thing, the exact same thing. We did some examples in class to show why that is, but since kindergarten, when you have been doing subtraction work, you're actually doing some pretty awesome work with subtracting integers. All right, so let's take a peek at what we're gonna do today. We've got counters and zero pairs for this, but our process, no matter which method you choose for adding and subtracting integers, is always the same. We take our magic Harry Potter wand of a finger, we cover up our numbers, and we identify if we're working with a positive or a negative. All right, so here we go. We've got a -3. Take your finger and cover up just that -3. What do you see? A -3, but we know the negative sign is the same as the subtraction sign. All right, awesome. So we have a negative and a negative. We just identified this 3 as a negative because the subtraction sign and the negative sign are the same thing, right? Negative sign, subtraction sign. You would never know just by what you're looking at right now. The big takeaway for this one though, I've had some kiddos ask, wait, 2 negatives make a positive, right? Not quite, because I have a -3 and a -3. I don't have a connection between these 2 negative signs. It's kind of like I've got a parentheses and a number 3 kind of blocking the way for them to come together. So I'm just gonna draw the counter example, and then I bet you're gonna kind of see what we're talking about, especially with our next example. So 3 negatives, 1, 2, 3. 3 negatives. So question, do we have any zero pairs, a positive and a negative, that will cancel out? The answer is no zero pairs to cancel out, so I circle everything. And my answer is 1, 2, 3, 4, 5, 6, -6. Okay, let's take a peek at our next one. Starts off the same way. Take your finger, cover that stuff up. I've got a -6. I've got a -4. 2 negatives make a positive. And if we circle this minus sign and this negative sign, do you guys see how, especially with this parentheses, it even looks like it comes together to make a plus sign? Yeah, so we've got 2 negatives coming together to make a positive. So our 4 is actually positive. So let's draw our picture. 1, 2, 3, 4, 5, 6 negatives. 1, 2, 3, 4 positives. And now we're going to look for some zero pairs. Do we have a positive and a negative that will cancel out? There's one, positive and negative, positive and negative, positive and negative. Circle my leftovers, negative 2. Awesome. All right, let's take a look at the next one. Take your finger, cover up the first, or the last little bit. Negative 4. Take your finger, cover up just that negative 4. Positive or negative 3. Negative. So we draw our picture. 1, 2, 3, 4. 1, 2, 3. Our question we ask is, do we have any zero pairs? Do we have a positive and a negative that will cancel out? We do not, so the whole thing is our answer, negative 7. All right, let's take a peek at our next one. Positive or negative 4, positive. Positive or negative 5, negative. Draw your little sketch. 2, 3, 4, positive, 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 positive. 1, 2, 3, 4, 5, negative, 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 negative. Do we have any zero pairs? Yes, so many. Positive and negative, positive and negative, positive and negative, positive and negative. We're left with a negative 1. Awesome. All right, let's scooch to this one over here. Since we've done, actually, yeah, we'll just keep going in order. Positive or negative 3. We've got a positive 3. Cover up that guy. And now we have a minus negative 3. 2 negatives make a positive. So we've got a positive 3. Okay, y'all. Now let's keep this simple. We have positive 3, positive 3. This is a problem that you've done since like kindergarten. 3 plus 3 is 6. Nothing fancy with that one. All right, so our last one. Positive or negative 5? Negative. Positive or negative 5? 2 negatives make a positive. All right, draw your picture. 2, 3, 4, 5 negatives. 1, 2, 3, 4, 5 positives. Do we have any zero pairs? 1, 2, 3, 4, 5 of them. That means our answer is 0 since we have nothing left. All right, there we go. Subtracting integers with counters and zero pairs. The rules are super important. 2 negatives make a positive. That's when we are subtracting a negative. Our 2 negatives are able to come together. There's no number in between them from blocking them for coming together. And then so the subtraction sign and the negative sign are the same thing. If I cover this up, again, you'd never know if that was a negative sign or a subtraction sign. All right, there we go.